All right, thank you. Welcome everyone again. I'm Anna, and I do technical marketing with Rafael here at H2O.ai. So before we get started with the presentation, there's a few things that we need to make sure that you have. So first of all, you need to go into H2O.ai to make sure you have an account. So if you don't have an account, please create an account. And because we're going to be using this towards the halfway of the presentation when we do the hands-on experiment. And if you do have an account, please just go to Browse Labs and just wait for further instructions. So again, please go to aquarium.h2o.ai, create an account if you don't have one. If you have one, please log in. Once you create the account, you will get an email right away with the password. So please make sure you have that. If you have questions on how to set it up, we also have a link that you can go to and gives you step-by-step instructions on how to create an account. Okay?
Okay, so this is our basic agenda tonight. We're going to talk a little bit about automatic machine learning and the workflow and some tooling that can help out with that. Then we'll talk a little bit about extending automatic machine learning, right? And can we extend automatic machine learning? And if so, can we do it in such a way that it's open? And so we'll talk a little about that. And then we have this notion about recipes. So we'll talk about what is a recipe and the role in automatic machine learning that it plays. And then there's nothing like actually getting hands-on with the tool to actually learn more about it. So if you're not familiar with H2O.ai. We're a startup. We've been around for 8 years. We just recently got our Series D funding. We have a couple different product lines. We have this H2O3, which is our open source tooling, and we have a commercial offering, H2O Driverless AI, that's focused around automatic machine learning. And our open source is used by hundreds of thousands of data scientists around the world. Our company currently has about 185 people. Interesting factoid, at the moment we have 13 Kaggle Grandmasters. So we have 10% of the world's Kaggle Grandmasters working here at H2O.ai. We also have a whole collection of expert data scientists here, and we have offices around the world. So first, just to kind of level set, we have this whole process in developing machine learning models. Partly is we collect the data. We do some around data integration, data cleansing, and prepare the data to do machine learning. And then we kind of go through this iterative cycle where we do some exploratory data analysis, figure out what algorithms we want to leverage, do some feature engineering, do some hyperparameter tuning, and iteratively create models, right? And we're being recorded. It's also going to be on YouTube, so you can check it out sort of later. And so you could iteratively go through this process and create models until you kind of get a winning model, right? This can be a very tedious task, right? So this requires some expertise. So sometimes we hear customers talk about, it could take a lot of time to do this. Also, that expertise requires talent in the people to actually produce this, right? And at the same time, they want to kind of make sure that they can trust these models. And so many folks have been working on producing and automating this process using automatic machine learning. H2O.ai has a tool called Driverless AI that really focuses where the gray box is around automating the machine learning process. Machine learning has many use cases. Driverless AI has been used across many industries. It's a horizontal sort of tool, so sort of irrespective of the industry, you can kind of leverage it, whether it's financial services, healthcare and life sciences, telecom, marketing and retail, to kind of automate this machine learning process. So as we talk about automatic machine learning, right, not all automatic machine learning is created equal. There's lots of different vendors who are starting to get into the space. We're really looking at maybe the 4th generation of automation in this. Here's sort of a listing of some of the different capabilities that Driverless AI focuses on around its automatic machine learning platform. Driverless AI today is focused on supervised learning. So we can work with IID data in a tabular format. We have some special recipes around time series and being able to do forecasting with time series data, and also some special recipes around NLP. The NLP is really focused around doing document categorization. And then, our tool can leverage both CPUs and GPUs. One of the latest features that came out this summer is this whole notion around bring your own recipe. And we'll talk about, how that can be leveraged to kind of take that automatic machine learning to the next level. So part of our mission at H2O is this idea around democratizing AI. And part of democratizing AI is being able to bring these tools to as many developers and data scientists as possible. So some of that's happening via our open source tooling, but also be able to get it as many people that can, we can automate this so they can take on even more use cases. And so along those lines, we also have this notion around we want to make every company an AI company, right? And as we look at trying to make every company into an AI company, we need to address the challenges around the lack of talent and how much time things take. And, automatic machine learning is really helping make that possible. But we really see this as a two-prong approach, right? One is, in order to really make this, enable this at a greater scale, we want to have a tool that can do automatic machine learning. But as we kind of looked at the different use cases across different verticals, automatic machine learning can help and address many use cases, but sometimes some use cases need additional customization, right? Sometimes you might need to want to leverage additional algorithm. Sometimes you might want to leverage a different log loss function for what you're trying to optimize for your particular use case. Or sometimes you have IP within your company as far as particular feature engineering techniques that work well for your particular business case. So you want to kind of combine the ability to kind of leverage automatic machine learning with the ability to customize that. And so this is where we have this notion around making your own AI. So this automatic machine learning tool has this sort of optimization that optimizes building these models where we can kind of take in data, do the hyperparameter tuning, select algorithms, do feature engineering in an iterative fashion, which is fantastic, right? This is that first step in that journey to make your company an AI company. So what happens with that is we've also tried to run into certain challenges, right? One of the challenges is customizing it for your domain. So maybe there's some additional algorithms, some feature engineering that you want to leverage. Or, in the case of some companies is they like this ability to automate the machine learning process, but they want to kind of retain some IP, right? They have some particular differentiation technology that they don't necessarily want to give back in the product or put it back into the open source. And they want to kind of keep up with the latest innovations in AI. I think this summer there was a lot of innovations around the NLP capability, right? Whether there's BERT, I call it Sesame Streets in NLP, right? So there's BERT and Ernie, right? Which are recent algos in development around NLP this summer. So you want to be able to keep up with these latest innovations. So not only do you want to have a tool that is great from a base, but that you can customize as your needs sort of demand, right? And so what we've done is we've taken this machine learning optimization framework and tool platform, and we've opened it up, right? We extended it so now it's pluggable. So with that, you can kind of plug in your own transformations for feature engineering. You can plug in your own log loss functions for custom scorers, or you can extend it with additional algorithms, right? And so this gives you a sort of a modular and extensible automatic machine learning platform, but also you can, with those customizations, not only is it extensible, but it's also open. And part of the open is that we put many of these additional customizations out in the open source. So tonight, as you kind of work through the exercise, we'll kind of hit the H2O.ai catalog, look at some recipes that we have in the open source and plug them in and extend the automatic machine learning capability. So with that, we have this data that comes in. We have this UI where we have over 100 recipes that our expert data scientists and Kaggle Grandmasters have developed that's out there in the open source. You can go to catalogue.h2o.ai and you find them all there. And so you can leverage any one of those. Or we have a series of API that allow you, if you don't find something, if it's not already in the box and it's not already in the catalog, it's an open platform that allows you to extend it and use our API to add to it. So how does this all work, sort of from the workflow? So, Anna, during the sort of tutorial hands-on, we'll kind of walk through this process, but Driverless AI has this whole collection of connectors. Those connectors allow you to connect up to a whole collection of data sources, whether it's on the cloud or on-prem. So you can connect to, HDFS and object stores and different relational databases via a JDBC connector. We also have this notion of a data recipe that basically, if anything you can run in Python and can connect via Python and get back a data frame, you can feed that to Driverless AI. And once you kind of load the data, you can start the process of doing exploratory data analysis. So we have this notion of we want to use AI to do AI. And so the first, your first flavor of seeing something like that is our sort of automatic visualizations. So depending on the patterns that we find in the data, sometimes it could be 6 graphs, sometimes it can be 13 graphs. We'll kind of show, here's the interesting patterns that are happening in your data, right? And we'll automatically generate those graphs for you. Then we enter the iterative process of building models, right? And this is where we select algorithms, do the hyperparameter tuning, right? Do the feature engineering. And if you've leveraged something from the extensible and open infrastructure, you can kind of plug that in. And out the other end, once you kind of get through this process, you'll have a model. At that point, you can either look at further explanations of that model and kind of see, hey, what's happening? Why are you making these particular choices? You can kind of look at an automatic report. It's like a 30-page report of how everything was built along the process. And after you kind of evaluate those things, you're ready to deploy. We can give you an artifact, an automatic pipeline via Java or Python or R that includes the feature engineering and the model that you can then take into a deployment environment, right? So those are the 5 general steps that we'll go through in the tutorial. So as we kind of go through the tutorial, we'll first start off with building a model without any of these extension points. And then we'll kind of look at the catalog, select some extension points that could be interesting, and then start extending that. So just to kind of clarify, this whole, what is a recipe? So as we look at our workflow around automatic machine learning, when we look at that workflow, each of the different elements in that workflow, if you break it down into various building blocks, each of those building blocks we refer to as a recipe. And so some of those recipes around transformations or feature engineering, or their data set recipes, or their algorithms, or their scores, right? And so this notion where we provide this open and extensible automatic machine learning platform, the feature that delivers that capability is called bring your own recipe, right? So many of these recipes are in our catalog, are in the open source. There's a GitHub repo. You can go check it out. One, you can explore the existing recipes that are out there. And 2, you can kind of look at some samples and examples in case you want to extend one or build your own recipe. And we have a series of tutorials for both of them, one about just consuming recipes and the other one about how to build your own recipe. So with that, I'm going to get Anna so we can get you hands-on with this.
Awesome. So thank you, Rafael. So now we understand a bit more about what H2O Driverless AI is and what recipes are and how they fit into the overall workflow. So right now, what we're going to go over, we're going to try to figure out how to use custom recipes. So we're going to import a transformer, a custom score, and a custom model. So the way that we're going to do this is we're going to go over one of the tutorials that we have. So as Rafael mentioned, we do have a site where we have various tutorials. We have it for both Driverless AI and H2O. So the one we're going to do today, we're going to do get started with open source custom recipes. Again, we're going to import a series of custom recipes. Okay, so again, for those of you who have not, who came in maybe a little later, please make sure that you have an aquarium environment. How many of you have the aquarium environment set up? Because we're going to go through the lab. Do all of you have an aquarium environment? Can you please raise your hand? How many of you need help getting aquarium? 2, 3 people? Okay, so we have Franklin and Rafael will walk around. Okay, so I'm assuming then the rest of you are already in aquarium, and yes? Okay. Okay, so if you're already in aquarium, you're gonna click on Browse Labs, and then from there, you're going to select lab number 6, which is Driverless AI Test Drive. Are all of you in Driverless AI Test Drive? Lab number 6? Yes? Okay. So again, this is a tutorial that's online. That is online. If you would like to do this on your own, you can also do it at your own pace, either later on today or some other time. So you're going to click on Start Lab. Again, this is lab number 6, Driverless AI Test Drive. And Test Drive is a 2-hour session that you can use of an instance of Driverless AI. After 2 hours, all the data that you have there will be deleted, but you can always come back and just do another session over and over again. So we're going to select the Driverless AI, and you should see something similar to the image there. Okay, so are we all there? Yes? Yes. Is that big enough? Yeah? Okay. Okay, so, all right, so the next part that we're going to do, so we're going to use the Kaggle dataset for telco churn data. So we're going to figure out, we're going to use that dataset as a base. We're going to build a base model where we're going to determine what will be if we can build a model to figure out what customers will churn. And so this is a very famous data set. If you have more questions about where the data set came from, you can go to the Kaggle site, Kaggle website. Here you go, hold on. Go around 1 sec. Okay, well, it's on Kaggle. But okay, so the way we're gonna start, we're gonna go to add data sets. First, we're gonna import the data set, and we're going to import it from their file system. So we actually have the data set in the Driverless AI file system. So if you go to file system, and then you type in, you go to data, and then Splunk, and then you go to churn. That will be your data set, and then you can click on import selection. Okay? So again, the path is data, Splunk, churn.csv. Any questions so far?
Anybody need help?
So right now, all we're doing, we're just importing the data set. Okay, so we're going to click import selection. Okay, so now we're just going to take a quick look at the data set. You can click on the data set and select details. This page will provide you a summary of the data set. If you want to have an overview of the type of the rows and features that are available or with this data set, you can click on data set overview. Okay. All right, so again, what we're targeting is churn, the column churn here. Okay, so now we're going to actually build our base model. So we're going to select predict. And we don't want, if you want to do if this is your first time using driverless, you can get a tour a little bit later. But for now, we're just going to select not now. Okay, so we're back. This is the experiment page. Um, can everyone see? All right. Okay, so we're going to select the target column, which is churn.
Raise your hand if you need any help.
Louder or? Oh, zoom in. It's already zoomed in, so. Is it too small? Oh, okay.
Probably want to zoom out because it's stretching.
Yeah, I reset it, but it's still showing. Okay, well, can you see that? Is that a bit more, is that clear? A little bit? Okay.
What you want to do is use the special mode for zooming in on the screen using. I don't know how to describe it, but it's basically.
How about F11 full screen mode?
11?
No, it's not that. It's, you want to be able to zoom in pixel wise without changing the browser itself.
Okay. Okay, well, let me see. All right, well, for right now, we're going to just kind of get the base model started. And the way we're going to do that is we're going to adjust the settings a bit just so that we can get the model running quickly. The training settings that we're going to select are 5, and the time will be 1, and the interpretability will be 8. So again, right now we're just building a baseline, and then we're going to incorporate other
It's
custom.
accessibility settings or zoom in settings if you want to take the time to do it. Otherwise, just.
Okay, okay. So we have, does everyone have the settings for 518, training settings 518? Everything else should remain the same. All you're doing is the target column is churn, training settings are 5, 1, and 8. Everything else should remain the same. So at this point, what driverless AI is doing, it's saying, hey, this is what I think would be the best optimized settings for you. So the optimized setting was 7 to 8, but because it could take a bit more time for just the purpose of the training, we're just going to do 5, 1, 8. Okay. Any questions so far? Okay. So launch the experiment. So while we're doing that, please just change the name of the experiment to base experiment. That way we can compare it later. Okay, so now we have a base experiment. Now we're going to import the custom score, and custom transformer. And the transformer that we're going to select will be SumPy. So one of the things that driverless has is that it's capable of adding up to 2 columns. So what if you wanted to add additional columns? One of the things about the data set that we do have is that we have customers who have some of the features are that they have the number of minutes that they call during the day, the number of minutes that they call during the evening or during the night. So we want to figure out if we can add those columns together, and the way to do that will be through a sum transformer. It's a custom transformer. So driverless AI has already transformers that that we believe are the most optimal, but you can incorporate your own custom transformer. So the way we're going to do that.
So you might be wondering what's going on in the screen, right? So just to kind of sort of level set, so it has 1 GPU. It's going through the process of building models. So on the bottom left, what you see here is different models that are being built and in different iterations, right? So the current winning model at the moment is XGBoost GBM. It's built somewhere in the order around, 10 models in the last minute, 30 seconds, right? Each one of these is a different model. So sometimes, let me see. Can hover it correctly. So as I select it, I should be able to, so I can see that this is using LightGBM. So there you can see different algorithms being used. You can also see the variable importance changing. So each of these models that were built, it has a different variable importance. In each iteration, there's different hyperparameter tuning that's happening, different feature engineering that's being leveraged, right? And it continues to kind of go through that process. The log loss function, so lower is better. So you can see that the current model is 1730, and it's going through this process in an iterative manner. We use a genetic algorithm to keep kind of doing this optimization. So that's kind of what's happening in the background.
Okay, so
Question: how did you do the cross-validation initially? Divide the training and the...
So we didn't do a split.
You didn't do?
No, but if you wanted to do a split, you could do that. So if you click on it and you just say split, you could do a split. And then when you launch an experiment, you can add a test data set. Now, every time we kind of run through it, we do cross-validation on the training data set. So we automatically do that for you. And if you want to have a holdout data set in the split, you can kind of create that holdout data set.
So what is your default value for that one, the cross-validation, the splitting and stuff?
So the split is going to, you can create your holdout data. So you can do 80-20, 90, whatever, 90-10, however you want to kind of do that. The cross-validation on the training data set, we kind of break it up in various folds, kind of depending on your data set. Yep. Any other questions? So that's sort of the very quick sort of introduction to that. Now we're going to take that and kind of keep extending it.
okay, so now we got our baseline. So then we're going to go back to experiments. So the experiment that you're currently working on, this is the base experiment. It'll keep running. So what we're going to do now is we're going to incorporate the custom transformer. So to do this, we're going to go to the experiments, and we're going to create another model with the same parameters that we just ran for the base model. So we're going to click on the model. Sorry. And then a new model with same parameters. So this is the part where we're going to incorporate the custom transformer. Okay, so we're going to go to expert settings. So everything else remains the same, right? We got our base model. Training settings, the training settings remain the same. So we're going to go to expert settings. So one of the cool things about version 1.8.0 for driverless AI is that we actually have a link that will take you directly to the GitHub repo where all the custom recipes exist. So these are recipes that have been created by our Kaggle masters and data scientists, and they exist here. So if you have any questions about the recipes themselves, what a recipe is, what are some of the best practices, safety, performance. If you're actually looking to write your own recipes, there's templates for transformers, for scores, for models. So specifically, one thing to note is that you want to make sure that if you are importing your own recipe, you need to be aware of the type of the version of driverless that you're using. So driverless is very sensitive to the version of driverless it's very sensitive to the version of that the recipes have. So if you're using a recipe from 1.7 and you're trying to put it into driverless AI and it's a 1.8 version, it will not work. So right now, if you notice, if you click on it, it takes you to the correct branch. So we have different branches with very different versions of the recipes. So just keep that in mind. So there's 1.7, 1.7.1, 1.7.2. We're currently working with 1.8 because this is the 1.8 release. Okay, so right now we're going to go to transformers. And we're using a custom recipe to be able to add more than 2 columns in driverless. And then we're going to go to numeric. Then we're going to go to SumPy. That's the transformer the custom transformer we're going to use. So here's another key thing. You need to click raw. Once you hit raw, you take the URL, you copy it, and you go back to driverless AI, and you load the custom recipe. Yes? You're raw? Okay, so let's go back. We are at Driverless AI, the recipes, the repo. We are going to go to transformers, numeric, and then we're going to look for sum pi. So as you can see, there's a lot of different transformers that you can pick from. They are custom, they're open source, and if you are always welcome to take one of the, take them and play with them, take them as a template and you can build upon them. So right now I'm just gonna show you how to import this one. In order for you to import it, you have to select raw and then take the URL, copy it, and then bring it back and then paste it where it says load custom recipe from URL. You can also do it from your local machine. If you have the recipe, the Python recipe, you can upload by selecting upload custom recipe, but because we're doing it for the URL, we're going to click load custom recipe and then just paste it. If you try to paste the URL and it's not raw, it will not work. You'll get some errors. So driverless is really good about telling you like, hey, this is not working. Go back, and it will give you really good error messages in terms of how to fix it. So as you saw, everything went well. The recipe's there. So how do we know that the recipe is actually there? So we're going to go to recipes, and there's a section here that says include specific transformers. We're going to select values, and the highlighted recipes here for transformers are the transformers that are by default inside driverless AI. So as you can see, we have at the bottom some transformer. That's the new transformer that we just imported. That's the custom transformer. You notice that it's not highlighted because you need to actually select it. So we're going to select it, and we're going to see whether driverless AI, yes?
So is everyone there? Does anyone need help? Okay, we're good.
Good? Okay. So we're going to select some transformer, and we're going to click done. So one of the things about your custom transformer is that it treats every custom recipe as an equal. That means that as an equal, it has to compete with all the other recipes. So that means that that means that it has to compete with all the transformers. And if driverless sees that it's not that the new transformer is not optimizing the model, it will not use it. So it's a very competitive environment. But you can always, so we're gonna run the model and see whether or not it actually incorporates it. So how do you know if it's actually there? Well, one other way to look at it, if you look on this side of the experiments page, you will see under interpretability, you will see sum. That is telling you that the sum transformer is there. Okay, so now all we gotta do is now launch the experiment and let it run. And we can come back later and see how the sum transformer affected the feature variable importance. We'll be able to see it here in the section here. Okay, so now we're just gonna move on to the next transformer. To the next custom recipe. Any questions so far? Yes?
So here you are applying the transformer to all the features, right?
Yes.
But what if some features are like Boolean features? So summing doesn't make sense.
Oh, no, I'm sorry. It's only going to be for numerical values. So no, it's not going to be for Boolean values. It has to be able to add, so for instance, we're adding minutes, right? So you have to understand like the type of data that you have, right? You will not be able to, if you look at the recipe itself, you'll be able to.
Columns which had, will it ignore it by itself, or do you have to remove those columns first?
You don't have to remove them. You'll be able, if it's a numerical value, if it's an integer, right?
But
The float.
0 is also integer, right?
Well, for Boolean values, I believe it doesn't, you don't have to remove them. According to the recipe, I don't see that.
Yeah, the recipes also have different condition statements. So it's like, if the recipe only applies to certain conditions, you can kind of give it particular settings so that, so you could load the recipe and select it, but it still might not select it still might not be shown just because this is for a regression and this is a classification problem. So you can kind of give it certain preconditions that it checks before it even starts trying to apply it.
Right. Thank you, Rafael. Okay, so now we have a base experiment and we also have a custom transformer at this point. So the second experiment, we're going to change to custom transformer. So that way we know that that's what we just imported. And we can do the comparison later. Okay, so now we're going to, again, take the base experiment so that way we can get the same parameters. And now we're going to import a score, right? A custom score. Okay, so now we do the same process. We're going to go to expert settings. We're going to go to the official recipes site. Even though we already been there, it's good to click the site. Everyone there?
So then you went and created another experiment, right?
Yeah, so we went, okay. So I went to experiments, and I took the base experiment that we started with, and then we went ahead and created another experiment. So a new model with same parameters. Okay. Okay, so that will then, we're going to use that new model. I think I created here. But we're going to import a new custom score. Okay, so we're back again to the section on expert settings. We're going to go to the official recipes external link. So that way you always make sure that you're going to the correct branch for the recipes, because as Rafael mentioned, we're constantly creating recipes. And so if you go here, there's always going to be master. There's going to be master. There's always going to be other people adding recipes. So you want to make sure you're in the correct branch. Okay, so let me see.
What's the name of the recipe that you're trying to?
For the score, it's called Breer loss. So it's a custom transformer. I'm actually gonna walk you through that right now. Okay, so for this score, we're going to go to scores. And then we're going to select classification. So notice that we have classification, regression, and there's also a template in case that you want to try this on your own and try to create your own score. And I just want to point out that if you click on the template, it has some really cool additional hints for you to be able to build your own. It's very informative in case you want to give this a try on your own. So we go to classification, and then we go to binary. And we're going to click the Breer loss.py. Is everyone there? Okay, so we select that, and again, we're going to click raw in order to import the recipe. So it's the same pattern. We go to load custom recipes from URL and just paste it, and we save it. And notice that if it has any errors, Driverless AI will let you know. If there's errors, please fix. Especially if you're building your own recipes, you will get a lot of additional feedback in order for you to improve your recipe. So
just as a checkpoint, so far we brought in a custom transformer, a particular feature engineering technique to kind of help try to enhance the model that we're building. And then we're getting a custom log loss function, right? So as Driverless AI tries to optimize the model, it's optimizing the model for a particular log loss function. And so in this case, it says, hey, sometimes people, we recommend maybe RMSE or log loss or F1 or F2. These are different sort of log loss functions that are sort of out of the box. But I want to use a custom log loss function to sort of optimize the model. So if you have your particular requirements of how you want to have the model be optimized, you can give that to us via a customized scorer that then Driverless AI will use to optimize the model. That's what we're in the middle of.
Right. Okay, so how do we check that the recipe is actually there? Again, Driverless has the option. You can select include specific score. So you can actually see the type of the scores that come with by default in Driverless AI. And if we check, Breer is there. So we just incorporated that. So now if we can actually just select done. So we save it, and when we go back to the experiments page, Driverless AI is still telling us, hey, the best score for this model is log loss. But what if you don't want log loss, right? And that's what Rafael just mentioned. What if you want to pick another score? So we go ahead and go back and click on the log loss, and we can pick Breer, which is the score that we want, that we just imported. Okay, so again, settings are 518, 5 for accuracy, 1 for time, 8 for interpretability, and the score is Breer. Any questions so far? Questions? No? Okay. All right, so now we just launch our experiment. Yes?
Out of my curiosity, have you ever used it in one of the Kaggle competition to see how it works?
Yes.
Yeah. Yeah, so that's a part of our sort of testing own benchmarking. We kind of try different, this churn one it's a Kaggle data set. So internally we test ourselves, right, with existing Kaggle competitions and the other data sets that we have to kind of see how we're benchmarking. There's one customer that I worked with who was in Paraguay, right? He was probably one of the earliest Driverless AI beta users. And so he was in a competition, not Kaggle, but a similar Kaggle competition where they were also kind of looking at churn. And he used Driverless sort of independent of us and was able to come out, I think, 12th in that competition. Yeah. So so that's one way to kind of like, okay, let's see the capability of the automatic machine learning. I think the other thing is that we typically see with customers is if you're a data scientist and you're building models, you know the effort that it takes you to get to a particular level of accuracy, right? So many times we can surprise some data scientists by being able to meet or exceed the effort, right? And there's a couple different blogs out there that I can try to share with you afterwards, where customer X built a model, took them 3 months and 2 people to get to a particular level of accuracy, and then ran driverless 3 different experiments in 4 hours and beat that level, right? So we're not trying to say that you will always beat that level, but the fact that we can sort of automate this process, hopefully meet and sometimes exceed that capability in a much shorter amount of time, with maybe someone who might be a little bit more novice in that particular space can be a big game changer.
Question is that we can allow to use H2O Driverless, to participate in competition?
Yeah. So if you can use H2O Driverless to participate in a Kaggle competition.
Okay. All right. So just to summarize so far what we have a baseline, right? That we're using the default settings that Driverless is suggesting for us to optimize a model. And then we went ahead and we incorporated a new custom transformer. And then we also went ahead and incorporated a custom score. Now we're going to incorporate a custom model. So again, similar process. We're just going to use the base experiment to use the same settings. So we go ahead, we go to base experiment, new model with same parameters, and it's the same process. We go to expert settings.
Can I do one?
Yeah.
So I just want to show one thing. If you actually click on the models tab, so these are some of the models that are sort of out of the box with Driverless AI. So you can see XGBoost there, a couple double flavors of that, a GLM, a LightGBM, TensorFlow, FTRL, RuleFit, right? So these are some of the models that are there out of the box. And what we're saying is, hey, there's an additional algo that I want to leverage, and how do I bring that into this environment, right?
Okay. And if you do have one and you want to learn how to do it, this is exactly what you could do. So again, if you have something on your local machine, you can upload it from your local machine by using upload custom recipe, or you can use the existing ones that we have on GitHub that have been created by our Kaggle masters and data scientists. Okay, so for the model that we're going to use extra trees. So the extra trees is not something new. It's from scikit-learn. So if you're interested in learning more about extra trees, you can go ahead and check out scikit-learn. But it doesn't come in by default in Driverless AI. So if you want to bring it in, incorporate it, again, you go to Driverless AI recipes, you go to models, and then we go to algorithms, and you'll find it here. It's called extratrees.py. So it's the same process. You're just clicking you're clicking on the recipe, and you select raw. You copy the URL, and you go back to Driverless AI, and you import. You paste it, and there you go. It should take the models usually take a little bit longer because there's some testing that the Driverless AI does when you import a recipe. So it needs to make sure that the recipe needs to pass a test that they have. So if it passes the test, then it gets imported. If it doesn't pass the test, they'll tell you like, hey, it didn't pass the following test. Please go back and check it. So this one's been verified, and so it should work. It does take a little longer. Any questions? Good. Okay. All right. So far we just added the custom recipes, and we said, okay, driverless, if you feel that it's incorporated, if it makes it, don't incorporate if it doesn't meet the standards, or if it doesn't think it's going to optimize the model. So, but this time what we're going to do is we're going to select the model, and what if we actually want driverless to just focus on extra trees? We don't want any of the other models to be selected, because it could be that XGBoost can actually do better than the other models, so it's not going to get selected, right? So we can actually uncheck all the different models that are here by default and just pick the one that we just imported. So again, you could just uncheck and select the model that you just incorporated. Any questions about that?
How did you get there?
Okay, so the way I went here again is, so we created a new base model. We went to the expert settings. We went to recipes. Since we already imported the model, I went here where it says include specific models. Select, and then I went to uncheck all. So if you uncheck them all, then you can actually highlight the one that you want, extra trees. Okay, so that just tells Driverless AI, like, this is the only model that I want you to focus on. Okay, so now we just click done, and you save it. And if you look on this side of the experiments page, it'll tell you here, extra trees, models. Usually this is where you will find the type of model that it's using. Most of the time I find that it uses XGBoost. It really likes that one to optimize models. So now you're telling it, this is the only model that I want you to use to optimize it, to optimize my model. And you click launch experiment. So this is, we're just gonna rename it. So this is our custom model. Okay, so now at this point we have 4 different experiments. And remember, the settings I adjusted so that we can actually do this hands-on experiment. Typically, the experiments run from 5 to 10 minutes, depending on the settings. Sometimes they could take a little longer, depending on your data set. But I lowered the settings so that we can get through the experiment a little quicker. So one other thing that I want to point out about Driverless AI is that, well, that's great. I have 4 different experiments. How do I do it to compare? I mean, this doesn't look very, like, it's not too easy to compare the models, right? So we actually have projects where you can go ahead, create a new project, and you can compare side-by-side experiment results, which I found very useful. Yes.
Yeah, yep. So that project is on the very top left. So go ahead and click on that top left projects and create a new project.
Okay, so we're just going to call it telco churn, which is the data set that we're using. Okay, so the way that we're going to do this is we're going to link the data set. So churn, that's the data set that we just used to run our base experiment and the other additional experiments. And we're going to link the experiments. So we ran 4 experiments, right? We ran the base experiment, which that's one. We're going to link the other one. We're going to link the custom transformer. Customer. And then we're going to include the custom score and custom model. Okay, so now you have your 4 models here. And you can only do 3 at a time. So we can create look at the base, look at the custom transformer. Oh, sorry. And we can look at the score here, and we can compare the 3 items. So now you can actually see the experiment summary for all 3, and you can see, okay, well, how well did one do compared to the other? And we can also look at the variable importance, the confusion matrix, ROC curve, the precision recall, lift, graphs, and so you can do that side by side. And especially when you're looking at the custom recipes, you can also look at the custom recipe and look at what driverless AI recommended for you to optimize. Okay, so just to review what we did, we covered how to upload a custom transformer, how to upload a custom score, and a custom model. Any questions about the process? So this is more about the process of getting the custom recipe into driverless AI. You guys have any questions about that?
Yeah, I think in the intro I kind of asked, how many people are new to this is the first time you're doing driverless AI so congratulations, you guys just went and built 5 different experiments. Not only did you build 5 different experiments in less than half an hour, you also extended them and plugged in customizations into it. So it can be that easy, right? So it's driverless AI is very easy to use, very powerful. As you've probably been kind of looking at the different UI, it gives you a lot of metrics back about what you can do and the result of the particular model. We can, part of the idea is that driverless AI tries to pick the best models, the best feature tuning techniques, and sort of the best hyperparameter tuning, and kind of do it in an iterative fashion. But we also want to be open and extensible, so that allows people to kind of bring that infrastructure or your knowledge into this particular environment. And as it optimizes, the process of building models, we want to do it in a simple way and give you all the metrics so you can kind of see and choose if this is what model works best for your company, right?
Okay, so just to recap, we do have the GitHub page. So if you're interested in learning more about the recipes themselves, we have the GitHub repo, right? Which we kind of went over. We went over the different branches. We went over the different models, recipes, and scores, transformers that we have available. They also provide a lot of documentation if you're trying to build your own, which I highly recommend. There's a lot of really good information on the site. If you are curious more about the type of tutorials that we have a site that we are constantly working on creating new content. We have various tutorials for driverless AI, and we have new upcoming H2O tutorials. We have one Introduction to Machine Learning Part 1. We have Part 2 coming up soon. So please feel free to stop by and check out the tutorial.
So I know we went pretty quickly tonight, and so you might be asking yourself, what are all these other buttons, right? What if I have a time series, or what if I have NLP, or hey, I heard driverless AI has some machine learning interpretability. So the nice thing is that now you have access to Aquarium. You can launch that, and we have all these additional tutorials that kind of walk you through, kind of diving deeper into that. So that's our quick sort of introduction, and we kind of give you a path to kind of continue. I guess at this point, maybe we'll open it up to questions and take a few questions, and then kind of guess there's a few people here that can also help with additional questions or answering some of those questions. So yeah.
You've done a tremendous job laying out a path for typical data, but people have hit me over the head several times reminding me that that real data is never typical. It's always idiosyncratic. For example, cleaning, I say, gee, can someone write a generalized cleaning program? And the answer is, in fact, if you generalize it, you're probably not doing a very good job. You've always got to do cleaning manually because it's so idiosyncratic. And I would imagine that applies to other things as well. How did you overcome these issues?
So both Driverless AI and H2O3 focus on the process of building models, not on the data cleansing part. So I think one of my earlier slides in the process. Let me see. It's all those video games. So in here you could see that Driverless AI focuses on automating this piece, right? The data cleansing piece is sort of happening outside, right? So this is something you as a data engineer or as a data scientist still need to work with. And you can use your favorite tool for doing data prep and data cleansing. H2O, it does work with a tool called Data Table, kind of both from the R perspective and the Python perspective. But still, at that point, you have to kind of go through the process of manually doing that.
Where is the auto-scaling part in the driverless AI?
Can you say more about what you see?
For example, you have the terabyte of data to training data set, and you want to scale it in a large machine with some SLA that you have. For example, the model latency should be less than something. Yeah. So you put some constraint on that. How do you set up in the driverless AI?
So I think there's at least two parts to that, right? One part is scaling the data that you want to train with, right? So I think driverless AI today, depending on the data, you can really kind of use driverless AI, and it works on a single node up to about 0.5 terabyte, right? Yeah. So so that's where we're at today. H2O3, the open source, we can scale that to petabytes and petabytes of data. Okay.
And distributed nodes.
And distributed nodes. That's H2O3. Okay.
And the model is also distributed when you deploy it. Or
so the model. So once you've gone through the process of training, now you want to go to the process of deploy, right? Can you go bring up driverless and show the pipeline? So once you're done with an experiment, so just bring up an experiment that's completed. Yep. So once an experiment is done, you have these two options here. Build a scoring pipeline with the Mojo, or build it with Python. The Mojo pipeline you can deploy with Java, Scala, or R. And the Mojo is a model-optimized Java object. It's a binary representation of the model. So we have many customers who are in a sort of high throughput, low latency environment, and they leverage the Mojo to do inferencing and scoring on that. So sometimes 30 milliseconds, 50 milliseconds. Now it depends on the complexity of the model, right? So sometimes you kind of maybe need to set additional constraints on your model if depending on the throughput you kind of want to get. But one of the nice things about H2O is not just a tooling company building an automatic machine learning tool like Driverless AI. We started as an algorithm company, right? As an algorithm company, we developed this notion of a Mojo to kind of make it easier to go from training to deployment, right? And this Mojo artifact, not only is it easy to kind of package to deploy, but it's sort of optimized to kind of get you that low latency sort of throughput.
But you don't have any guaranteed SLA that shows after the training the driverless AI that this is the for this throughput, you get this level of the latency. Because, for example, the fraud detection should be the real time. It's not something that you go in a batch mode. So with that sort of application, how do you handle it?
Yeah, so I think you have to, for that kind of application, you have to kind of do some testing. We did a meetup with Groupon maybe sometime this summer, and they were talking about using H2O and sparkling water. And one of the architects, the data scientist there, he really wants a Mojo sticker, right? So in his case, he's deploying the model to Elasticsearch. So he's using Elasticsearch and kind of doing the scoring, and he has a sort of a range within 50 milliseconds to do the inferencing, and he's getting that kind of throughput with his Mojo for his particular model. Now we don't have any click button. Here's the latency and throughput. You'll have to do some testing. I don't know, Tom, if you have anything else you want to add here.
We have bookings.com file that's doing it in 7 milliseconds, so near real time as well.
Yeah. So we have several customers who are doing it, in sort of millisecond sort of time frames.
So I would say we have many large banks that are using this platform exactly for the problem of real-time fraud detection latency for the real-time card swipe. This is an excellent platform for that problem with sub-millisecond response latencies that are very, very consistent. So the Mojo is a very, very performance-oriented, real-time scoring-oriented artifact. It's basically a very thin runtime that is embeddable in lots of different environments in various languages and does an excellent job of that problem specifically, as well as many other problems.
Almost get whacked in the head with the microphone there. Any other questions? Oh, let me go around with the microphone. This is part of my exercise program for tonight. Work down the pizza.
I was just wondering about how it works if you have beliefs about your data, like if you think you have selection bias, or if you think part of your data set is high quality data and another subset's low quality. Can you do anything about that?
So maybe I heard two questions there. One question around leaks. So if we kind of went through the experiments page pretty quickly, but when an experiment is running, you get all these notifications, right? So you can get a notification if it detects an imbalanced data set, and maybe give you some suggestions of some additional settings you can use to kind of improve that. We also kind of do leakage detection. So I've done experiments with customers where part of the first thing that we do is kind of run a base model to kind of go through the notifications, see what features might have data leakage, have a discussion with the customer around those particular features, and then maybe kind of remove some of them, right? I think the other thing, you had a question around bias, right? So one thing we didn't show tonight, if we go back to the...
Sorry, I just want to point out the part where Rafael talked about the notifications. So if you, I know it's hard to read, but if you're actually running your experiment, notifications will tell you the data is imbalanced, target class fraction 14.49%. So you actually get some additional information when you're running your experiment.
And if there's leakage, or we suspect some leakage, we'll sort of show you that. The other thing is around, you mentioned around bias. So one of the things that, there's two microphones. So I probably shouldn't use two microphones. So we can kind of look at something that's completed. And again, we have a tutorial just around machine learning interpretability. So that's another key strength of H2O as a company. So we can interpret a model. And this is going to do a couple things. It's going to generate a series of additional reports and explore different techniques. And also going to go through the process of generating some surrogate models to help try to understand the model that we built. And as we look at some of the techniques to understand what's happening with the model, one of them is called disparate impact analysis. So disparate impact analysis is a sort of report that you can look at to look at if there's potential bias in your data, right? So not only do you want to run through an experiment and kind of maybe address the data leakage, after you run the experiment, before you actually look at deploying it, you want to look at probably both the experiment summary to kind of look at the details of what happened during the experiment, and then maybe run through sort of some machine learning explanations, right, to the MLI report to kind of look at the details and see how your model's behaving. Yeah.
How to deploy and download this model? Yeah, how to deploy and download this model, and where you're going to do the deployment means how.
Yeah. So the question around deployment. So you can either download it as an artifact. So if you have a Mojo, it'll get a zip file. In that zip file, you'll have some example code that you can kind of look at how to actually do the inferencing, and kind of there's also sort of a runtime that's potentially necessary. So if you look at resources, you can kind of look at the Mojo runtime. You can look at the Mojo runtime for Java, Python, and R, and so you can download the Mojo pipeline, or in this case, I can build a Mojo pipeline. It'll build a Mojo pipeline. Once it's done building the Mojo pipeline, you'll have an option to download it, or you can actually kind of go through the process of then kind of deploying. So we have some deployment templates that makes it easy to deploy to AWS Lambda, and we have a built-in REST server that can then take the Mojo and push it out there. In a similar fashion, you can download the Python scoring pipeline. And the Python scoring pipeline, you can also download and have, again, it's a whole zip file with a whole collection of things, and there's some basic infrastructure there. Yeah. Oh, wait. Parallel processing. One person asks questions, another person stay here at the front. That works nice.
Thank you. Do you have any support for deep learning algorithms? I only see like scikit-learn is being prominently used in this one. Do you have any support for?
Well, in our tutorial tonight, we extended it with sort of XGBoost. Excuse me, the scikit-learn model. But if we kind of go back to, let's go build another one. So we can kind of look at the models that are sort of out of the box. So we click on models. So here's XGBoost, GLN, LightGBM. TensorFlow is also there, right? So as you look at sort of leveraging deep learning, so TensorFlow is sort of what we're using for some of our NLP capability out of the box. But as you look at the catalog for additional recipes, you'll find things like PyTorch there also, right? So I think there's a couple of other deep learning algorithms that you can leverage.
So do you have any out-of-the-box recipes for, say, custom NER models or image segmentation or anything?
Yeah, so one of the things is around image. So today, Driverless AI is really focused around tabular sort of data. But another fantastic resource is we just had H2O World New York. Let's see, YouTube playlist. Oh. Here we go. Hopefully it gets me to the right one. So in here, well, let me do one more try, and not my machine. So you can kind of go to H2O New York. In there, you can kind of look at the agenda. So there's Johan is one of our Kaggle Grandmasters. His expertise in particular is around image processing. So he's looking at some future work around being able to build image recipes with Driverless AI, and he's using this similar extensibility infrastructure to do that. So I would suggest checking out this demo in this session and kind of seeing where we're heading with some of our image recipes. Yeah.
Thank you for your presentation. What about natural language processing?
Yeah.
And also on top of that, let's if there is some recipe for NLP, how fast is the model training? Is that the same as the one that like you said in latency using the driverless AI to do it?
Yeah. So we have a whole tutorial here around sort of using driverless with NLP, and at the moment we're really focused around document classification. Out of the box for this particular tutorial, it leverages TensorFlow, right? So it's still, it still has to use that underlying TensorFlow algorithm to kind of build the models, and we automate the process of figuring out, hey, what hyperparameter tuning you should kind of leverage, but it still has to kind of go through that process of building. So it kind of depends on your data set and what you're trying to do. So there's that, but we can build a scoring pipeline for that using the Mojo.
How do you position your platform in comparison to the AWS SageMaker or Google AutoML?
The different cloud vendors all have lots of different tools, right? And sometimes they have multiple tools to kind of do different things. I would say that we can integrate with many of the different clouds. So you can use driverless in all the clouds. You can use the Mojo artifact to deploy them in there. So we have some customers who want to use SageMaker to actually do deployment. Because at the end, you want to try to build the best model sort of possible. Different folks have started with different strengths, right? So if you look at Google's AutoML, they really started more from the image side, right, than they actually sort of IID. And so, there's, different strengths and weaknesses sort of there. I think it's, the best thing for you to sort of evaluate it with your data set and see what kind of results that you get. We think for the use cases that we do today, we're one of the best options out there for that. And happy to have a further discussion sort of offline. Okay. Well, thanks a lot, folks, for coming out tonight. Actually, there's Manohar. So you can raise your hand. There's Tom. There's a couple of us here. So if you have sort of questions, feel free to come up and ask questions. We hope you guys come back to another meetup in the future. We want to keep doing this mix of some hands-on events and some sort of more sort of conceptual sort of meetup topics. So thank you very much for coming out.
So just one last thing. Yeah, if you want to just go ahead and do the tutorial on your own. I know we went really fast. If you want to do it step-by-step, we have the tutorial. It's available, and it has all the steps and further descriptions and explanations. Again, I know it's kind of quick today, but if you want to explore it on your own time, you have Aquarium now, and now you have the tutorial too as well. All the instructions are there. Thank you.